All right, and here we're going to talk about end behavior of polynomials. And so we're going to be looking, end behavior really is talking about what's happening on the far left and what's happening on the far right of a graph. So let's start out with a couple fairly familiar ones. If you have a function where it's just x to the first, it's going to look like a line. It might have a y-intercept, so it might look something like that. If you've got an x to the third, usually it's going to, come up, do a little dance, and then end up going like that. And so this stuff in the middle might look a little different on each x to the third, but it's going to look essentially like that. And x to the fifth is going to be very similar, except it's going to have another little hump in there. So there's going to be, that's a fifth degree polynomial. But what I want you to notice on all of these is as you look on the right of the graph, all of these are pointing up. And if you look on the left of the graph, all of them are pointing down. And so that's what we're going to talk about with end behaviors. What's happening on the far right of the graph and what's happening on the far left of the graph. So what we say for each of these is as x approaches negative infinity. So what this means is on the left. If it says as x approaches negative infinity, it's saying what's happening on the left of this graph. And so that's going to be over here on the left. What's happening to the y value? Well, it's going down. And so y is also going to negative infinity. And the reason that is, one more time I'll explain, is when it says x is approaching negative infinity, that means you're heading to the left. That's going, the x value is going to the left. And you have to look at what's the graph doing in the y direction. Well, it's going down. That arrow's pointing downward. So then if we look at the right side, as we go to the right, when x is approaching positive infinity, the y value is increasing. So that's going to be y is approaching infinity. And you know what? What's happening with all of these is they're all pointing the same direction. And so as x approaches negative infinity on the left, the y is going down. So they're all going to be the same. Same thing on the right side. They're pointing up. And so that means y is going to be approaching infinity as x approaches infinity. So basically it's saying on the right side, what's y doing? Well, it's going up. And so we'll come back in just a moment to talk about one other way to write this, but let's talk about kind of in general. And before we do that, I forgot, we were going to talk about what if the coefficient here is negative. So if you have a negative x, that means your slope's going to go down. And so it's going to look just like the previous one, except flipped upside down. And so same thing here with an x to the third. It's going to look like that. And an x to the fifth is going to have something like so. And so if you notice on the left, all of these polynomials are pointing up. And on the right, all of these polynomials are pointing down. So the way we write this is as x approaches negative infinity, so remember this just means what's happening on the left. So on the left, what's happening is the y is going up. So y is approaching positive infinity is the way we'd write that. And then as y approaches, as x approaches infinity, so as we head over here on the right, what's happening? Well, the y is pointing down. So y is going to negative infinity this time. And just like when the coefficient was positive, when the coefficient's negative, they all have the same end behavior. And so on the left, by the way, this is the right over here. On the left, they're all going to be approaching positive infinity on the left. And then on the right, they're all going to be approaching negative infinity because it's going down. All right, so in general, Actually, let's go back to that first slide. We'll come back to the in general in just a moment. One other way to write this, if you're taking a calculus course or a pre-calculus course, I got scrolled down a little bit too far there, you might start talking about limits. And so many textbooks will ask you to do answers like this. But if you're preparing for calculus, you might start talking about, well, the limit as x approaches negative infinity of f of x. So that's the way we would read this thing right here. We would say the limit as x approaches negative infinity of f of x. So what that means is we're looking at our function f of x. That's the first one. That's just x to the first. And it's saying, what's the limit as x approaches negative infinity? So basically, what's happening when x is negative infinity? Or this is really saying what's happening on the left of the graph. Well, it's going to negative infinity. It's going down. So this stuff over here on the right is just another way of saying what we just said. So the limit as x approaches positive infinity. Well, that's what's happening over here on the right. So that would just be positive infinity. So it's going to look just like the answers we had, where the limit as x approaches negative infinity of, oops, I meant to write g of x here. Forgot to do that. And then this one was supposed to be h of x. A little copy paste mistake there. So limit of as x approaches negative infinity of g of x, well, it's the same thing. It's going to be going to negative infinity because on the left it's going down. And then on the right it's going up. So as x approaches positive infinity, the y is going up. Same thing with h. So as x approaches negative infinity, that's over here on the left, the h graph is going down. So negative infinity, and the h graph is going up on the right side, so it's positive infinity. So that's just another way of writing it using limit notation, we call that. It's going to be the same thing here. I'm not going to go over that. So in general, for any odd degree polynomial with a positive leading coefficient, the end behavior will be what we just saw. As x approaches negative infinity, y also approaches negative infinity. So that was like a third degree polynomial. As we go over here on the left, the y is going down. So that's what this is saying over here. That's also what this limit thing is saying right there. And then same thing on the right. So as x approaches positive infinity, y is going up. That's what's being said in the bottom part. So that's just kind of an in general for an odd degree polynomial with a positive leading coefficient. What that means is that number out in front of the biggest exponent on x. So like if it's an x to the third, the number out in front of x to the third is positive, not negative. And then if it is negative, we saw that it was this. So if you're taking notes and you want to write this down, I'm not going to go through and explain it again because it's the same thing that I just said on the previous slide. All right, well, let's look at what if it's an even degree polynomial. And so this first one, if it's x squared, that is going to look kind of like a parabola. Not kind of like, it is going to be a parabola. So it's going to look like that. If it's an x to the fourth polynomial, it's going to be kind of a W shape. If it's an x to the sixth, it's going to be, I don't know what this is, a worm, something like that. But what you notice is, just like we were talking about on the previous one, is the end behavior on the left is the same for all of these. And the end behavior on the right is also the same for all of these. And so what's happening as x is approaching negative infinity, once again, this is just saying what's happening on the left. Well, I'll try to color coordinate this here. That's what's happening over here. Y is going up. It's going to positive infinity. And then on the right, what's happening? Well, it's also going up. It's going to positive infinity. As x approaches infinity, y is going to infinity. Same thing with all the other ones. On the left, the y is going up. And on the right, the y is also going up. So the way we write that using our limit notation that we talked about is, let's see if I can get this out of the way. There we go. Same idea. We're just going to say that it approaches infinity for all of these. And once again, I forgot to change these. So that would be G and H in this case, because that's what I use to define those functions. So whenever you have an even degree polynomial, they're both going to be going up. And so the limit, no matter on the left or the right, is going to be going to infinity. Now, you guessed it probably. What if that number out in front is negative? Well, it's just going to flip everything upside down. And so this graph is going to look like so. We're going to have an M instead of a W. We're going to have something like that. And so hopefully you're starting to kind of pick up on this. What's happening on all of these, on the left and the right, is it's going down. And so this time, instead of going to positive infinity, everything's going to negative infinity, because everything's pointing down on the left and the right. And then the limit notation stuff would look the same. So to kind of summarize this, for any even degree polynomial with a positive leading coefficient, we said that both the x or both the y values are going to go to infinity. Same thing with the limit notation. They're going to be heading to infinity for both of those. So this is with an even degree and a positive leading coefficient. So that was like the y equals 2x squared plus x plus 7 or something like that. This has an even degree, that 2, and the leading coefficient is a positive number. And then if we have an even degree with a negative leading coefficient, everything's going to be pointing down on both the left and the right. So it's going to look something like this. All right, so one last thing that we're going to talk about is what if we have some functions that look kind of like this. And so this one, the end behavior is not going to be going to infinity or negative infinity. It's actually going to be going to something. And so what I want you to notice here is that I've got a graph. It goes like so, and it keeps going. And the other part of this graph, so this is all one function. I just typed this into Desmos, and it made this graph for me. And then I also did, if you notice this dotted line here, I just wanted to kind of show you, it's a pretty ugly dotted line I drew. I'll undo it. But that's just kind of, it's called a horizontal asymptote. That's, I wanted to show you where this graph is going to get close to but not cross. And so what's happening on this graph is, let's think about this for a second. On the left, where's this graph approaching? Well, it's approaching this asymptote line here. Same thing on the right. It's approaching that horizontal asymptote. It's going to kind of level off as time goes on. And if you're kind of thinking, well, how do you know it levels off? You know, eventually we'll talk about when we graph rational functions, or if you watch that video, we'll talk about how do you know where it levels off. There are rules to figuring that out. So the end behavior of this polynomial is that as x approaches infinity and negative infinity, the function's going to approach 3. So instead of approaching infinity or negative infinity, it's leveling off at 3. So the limit would be approaching 3. So sometimes you'll end up with the end behavior being just a number, and that's where the graph would do something like this, where it would level off at that specific number. All right, so a lot of stuff to digest. Hopefully that kind of explains what the end behavior of a polynomial is. If it's some sort of polynomial where it's just a normal even or odd degree, not too bad. You just say it's going to infinity or negative infinity. Otherwise, if it's something like this where it levels off, then you say at what number does it level off.